Hello, welcome. Thanks for coming for my talk that will be covering the functional domain modeling in Scala. Oh, the remote is not working. Oh yeah, it's working. My name is Marcin Kustra, and I'm currently the Scala developer working at Evolution. I'm responsible for developing and maintaining the platform for integrating with external casinos. Our main goal is to ensure that our platform is scalable and highly reliable. I have overall 4 years of commercial experience in JVM-related fields, and at some point in time, I decided to move to Scala. It was around 2019, and I have to admit that it was one of the best commercial decisions I could ever make, so I highly encourage you to at least try with this language after this talk. I hope that I will be competent enough to show you why. I am mainly interested in programming in 3 fields. Those are functional programming concepts. Those are the immutability, pure functions, and other, and how one can construct the applications or inspire the implementation using those concepts. Also, I am interested in the infrastructure-related topics, especially taking into account the fact that recently more and more infrastructure-related tools are highly inspiring from the functional concepts, such as immutability. So that's why we have the containerization and Kubernetes orchestration and others. And also, I am interested in distributed systems. And those are the microservices, event-driven, and the others. I have decided today that I will remote is not working. No problem. I have decided today that this talk will set some goals. Those are, firstly, I would like to get you familiar with domain model implementation patterns, and I would like to ensure that we are on the same page. Those patterns are value objects, entities, and the aggregates. Firstly, I would like to highlight that this won't be an in-depth introduction because this topic is quite huge, but for sure I will then reference some other literature which will have this topic covered. Also then, I will show you how to implement those model implementation patterns so that we can make use of Scala free features. I wouldn't really like to show you yet another implementation in different language series. I would rather like to show you how one can use Scala free features in order to embrace its rich type system so that this implementation will look quite straightforward and natural to the developers. And also, I would like to point you how this implementation will be helped with the presence of the compiler, so that we will also embrace the compiler in our journey so that we can ensure that this code is correct. Also, in many cases, I will also show the references to external libraries that will boost your effectivity when programming in Scala. So it's very important to set some. I have missed one slide. So it's very important that for sure I will require from this implementation that the implemented domain will be of very high expressivity and efficiency. So that I would like to implement the model using the Scala features so that when I look at the domain model specification that we have discussed with the domain experts, and when I look at the code in Scala, I should be easily able to join the dots and find the places where something needs to be added or adjusted, or at least checked. I will also show you how Scala has, with its rich type system, will provide us the compiler that will be very, very powerful in that journey. So, firstly, we need to start with the domain model implementation patterns. We will start with the most fundamental one, which is called value object. Value objects can be used to group specific fields of properties together in order to increase the model expressiveness. In many cases, when we are speaking about the value objects, those value objects are identified by those grouped values. When we are comparing the value objects, then 2 value objects are only equal when they share the same properties values. If at least one of those properties is different, then we are speaking probably about 2 different value objects. That's why it is called value, because values are different and can be changed over the time, at least in the mathematician sense. Also, we have to point that value object, since its immutability features, does not carry any history. we can't really say that when we have given value object, then it has transitioned from some state previously and can have some behavior that may be indicating any history. Those are just immutable. This is just the information that will increase the model expressiveness. So let's take a look at the address use case. Probably we are modeling some customer. This customer may have some address information. So this is the form from our website that is providing access to our system. As we can see, address may contain different fields. Those are address line 1, address line 2, city, postal code, and country. So what do we expect from this address when at least one of the properties changed? Well, for this example, I have changed the city and the postal code. Those are two valid addresses, just for the information. And if we change those two fields, then we are resulting in a completely new address. Those are completely two different values. And the purpose of the value object is that every time we are speaking about the customer, we are not speaking that customer has address line 1, 2, city, and others. We are speaking that customer has its own address, so that we can communicate much more efficiently. But there is still one problem with value objects. Value objects are not really good enough to model the whole system. They do not carry any history. They don't have any state transition or others. We need something more specific, especially taken that this equality of the value object is very, very restrictive. Let's take a look at the customer. We are developing our website, which contains some customers. And let's assume that we have the Joe Doe. Joe Doe is trusting our website more and more and decided that at some point in time, he will provide us his second name. Let it be Marcin. So what in this case? Should this customer be treated as a completely new customer? Should we treat, for example, his order history as a completely new customer history? Rather not. And here is the problem that if you wanted to model this customer using just a value object, then those two customers, this one customer will be treated as two different customers. So we need something more specific to achieve that goal. This goal is to add some external identifier that will be assigned to him, and we would have the opportunity to identify the customer that we have in our system. So for example, we assign this customer ID1. So every time the customer changes his attributes, non-ID attributes, it is still pointing to the same customer. We are still speaking about the customer of ID1. No matter whether he added the second name or not, whether he changed his address or not, we are still speaking about the same customer. So that's the clue of the next domain implementation pattern, which is called entities. Entities is an object that is distinguishable via the explicit identifier. We are comparing two different entities in a way that we assume that two entities are only equal if their IDs are equal. No matter whether they share the same properties or value objects, it doesn't matter. All we care about the equality is that the ID must be equal. That's why we also say that entity state may store some entity state may change over the time. So entity may carry some lifespan, which may indicate that it has transitioned from some state from the past to the state to the future. So one would say that entities and aggregates, entities and value objects are enough to model the whole domain, right? Entities can also contain some other entities. So we can build a really rich dependency graph of different concepts in the model, and it should be fine. Well, the problem is with such design that at some point, our domain may be really, really nested and really, really complex. So that when we will be trying to reason about this domain and which operations can be done atomically or not, we'll have some troubles because all those entities will be related with each other. One entity will be contained inside another entity physically. And it would introduce some overhead and boilerplates in order to maintain it. Not to say that it is really hard to develop such system. For example, let's take a look at the shopping cart here. This one is taken from the Amazon. And this shopping cart contains, for example, some items. In this case, we have some book. So at the first glance, it looks like shopping cart should also contain the order lines, which should contain the reference, or at least the whole book that is provided here. But the problem is that the book itself may also contain some reviews or comments. Should those comments also affect our shopping cart? In case of Amazon, it's not the case. We only care about the product when it comes to the price and the quantity that is available to buy. So we don't really need the whole information. When we are operating on a shopping cart, we don't really care what are the reviews, what are the comments included, and others, what even the description of the book is. All we care about that we have some item, it can be somehow referenced, and we can somehow extract its price. Also, shopping cart has one important property, that every time we add some items or remove them, it is very important to us that the total price should be consistently updated. Because it will be a very disappointing surprise at the end that we have done some operations to this shopping cart. We have removed or added some items. The price is quite nice because it's very, very low. And at the end, we are trying to pay with cards, and it turns out that the price has changed. From the customer experience, it's a big disaster. That's why there is a third domain implementation pattern, which is called aggregates. Aggregates are also entities. Aggregates also contain IDs, but the aggregates goal is to also enforce some boundaries in the system. Aggregates are responsible for ensuring that its internal state is updated in a consistent way. Also, the updates to the aggregate should be done atomically. So, for example, when we are changing the shopping cart, we can't just expect that at some point when we add some items or remove them, then we will have the state that only reflects some of the prices or not. We are expecting that this change will be done atomically. Item is added, the price is well reflected. That's why we sometimes say that aggregates is also a transaction boundary, because when we are designing the system from the implementation point of view, aggregates are used in order to show how those transaction boundaries are looking like. Also, that's very important that since aggregate state can be easily modified outside, it means that we can simply take the aggregate state and mutate its field in place in a different arbitrary part of code. For example, we can just simply take the order line, update its quantity, and forget about setting the total price. That would be a disaster. That's why when we are trying to modify some portion of data of the aggregate, it's very important that this should be done via the aggregate itself. In order to do so, we can make use of the command pattern, which encapsulates the intention, so that when the aggregate receives the commands, aggregate should be also able to deconstruct this command and also do some appropriate steps in order to ensure its state consistency. Also, since aggregates are acting as a boundary, aggregates, since now, does not reference each other by simply composing them. Aggregates may reference each other only by using the special aggregate ID. And since we now know what value objects, entities, and aggregates are, let's move to the example that we'll be trying to solve over the rest of this presentation. Let's assume that you are working for a company that is highly specialized in selling the games. It, for example, used to be a physical store management, so that we've been going to the shop, buying some game, just looking at the cover, and we were happy. But, for example, since the COVID has happened, it looks like the gaming industry is going very well. And at some point, the physical management of the resources can't keep up with the load. So it's quite natural that game store management decided to somehow automate their processes so that the less humans are involved and the more software is involved. And we are happy, because now we have the job. We are now involved in this process. We are now qualified with designing the whole system. And after many discussions with domain experts, it turned out that we have some initial design of this model prepared. And here is just a small part of this design. This notation is taken from the domain modeling made functional book, which will be referenced at the end of the slides. But for now, let's focus on this model. We have, in the heart of this model, there is a game. We can see that game can be either in progress or released. And based on its state, this game has a different structure. So, for example, when you take a look at the in-progress game, it turns out that it contains the game ID, studio ID, and others. But what's more important, game description here is optional. Because, for example, the studios may change the description as the game is developing and more options are added. Also, game platform is optional. I mean that there may be many game platforms, but it's not required that at least one platform must be present. So it turns out that game platforms may be added or removed over the time, and we must be ready to reflect such change. Also, we have the planned release date that will be strictly used to inform the players or the potential customers that this game will be released at that date. But of course, the history and other studios has already shown that this date can be postponed really, really many times. So that's why it's optional. It can be changed over the time, no problem. And if the game is ready, we now have the field that is, we now have the state, which is released. Released game is a bit different in behavior and in its structure, because from now on, description must be set and can be changed over the time. We can't change the description of a game that has been already released. It's like with the cover of the game. You can't just simply go, take some pencil, and change the description. It's now permanent, and studios must deal with that. Also, game platform must be specified in a way that at least one platform must be provided. And also, since game is released for some platforms, one can't simply use the remove operation on the release game and remove the platform that this game has been released. It's not possible. If the game is released, then platform is fixed, and that's the other. What studios can do is that the game platforms can be added. So we can append some more game platforms as the game is developed for or ported to another platforms. Also, it's very important that the release game contains the patch field, the patch property, which is not present in the in-progress game. So patch field here indicates that the game may be updated over the time. There is a release date, customers are playing this game, and they notify that some of the properties of game are not OK, and they can report it. So that in response to those reports, studios can release some other patches, and it's important that those patches are released in a proper manner with the latest version. Every time the patch is released, latest version should also be bumped. So now we have this model. We ask what is the, we now know that the game is in progress or released. But of course, we need to go further. We need to go down the rabbit hole and ask for other properties, what the game ID is, what the studio ID is, and others. So I will just show some of the properties, and those are the game title, game platform, and patch. Game title, as we ask the domain experts, is just the main title that must be always present, and some subtitle, optional, but maybe appended to the whole game title. Also, there is a game platform. From now on, the game platform is just the indication that it's PC, Switch, Xbox, PlayStation, or Game Boy. Well, anyway, who remembers the Game Boy these times? But I remember. It was a really nice adventure in my childhood. And also, we have the patch. It's very important that, in this case, patch is an entity. That means that our game aggregate may contain the other entities. And this entity indicates that since it's embedded in the aggregate, that it alone can be referenced. It must be a reference via the aggregate. And it's quite natural choice, because when you are speaking about the patch, we can't really say that this patch is universal and can be applied to any game. When patches are released, they are released in context of some game. So, for example, when we are releasing the patch for the Cyberpunk, we are releasing the patch for the Cyberpunk and not for other game. So that's very important that it's embedded and must be updated with the game aggregate. So now it's time to choose the language. And there are really many topics about that, really many approaches. But this time, I will try to do it with Scala. Why Scala? Because Scala is a very flexible language that is gaining more and more popularity. When I was starting in Scala, it was 2019. There are really few job offers on the market available, and now it has grown exponentially, I can say, and it's gaining more and more production applicability. First of all, one huge benefit of Scala is that it is built on top of the JVM. So if you are quite used to the JVM tooling and JVM, for example, JVM tuning options, we can still apply them in Scala. Since Scala is built on top of the JVM, all the tools and the libraries that were written for Java can be also used in Scala. So that's a huge benefit. Because if at some point we really need some critical integration with other systems, we don't really need to re-implement the whole functionality. All we really need to do is to just look whether this library exists or not. Also, Scala has a really powerful type system. I mean that rather than simple classes and generics, Also, Scala offers the benefits like opaque types or algebraic data types, which I will explain later. But that's very important that the presence of generics, algebraic data types, and opaque types makes our implementation very, very expressive. That it's not really possible to do it, for example, in Java, since there is a lack for the algebraic data types, but it will be changed in the project Amber as far as I remember. Also, Scala supports the functional programming principles. Well, there is always the war between the object-oriented product programming and the functional programming because they are quite complementary to each other. They are on the opposite sides. But it's very important that Scala is a fusion of the object-oriented programming and functional programming. What I mean by that? So many languages tend to be either object-oriented programming or functional programming. For example, Haskell, which is a great language, is only related to functional programming. And sometimes writing the systems, just using the Haskell, may be painful. That's why Scala is a fusion, so that where functional programming can do its own, then object-oriented programming may be used. And inverse relation, where object-oriented programming can do something in a nice way, functional programming can complement it. By functional programming, we will be simply using today the pure functions and the immutability first. So that pure function will be taking some input, will do something on this input without mutation of the word and without the side effects that may change over the system. And we will return all the function will do will be returned in the type in the output, and it will be reflected in the type signature. Also, Scala contains a very rich standard library. I mean that there are really many possible options that are, in many cases, the wrappers on Java libraries with much more expressive DSL. But still, Scala is very rich with standard library. And with this library, we should be quite simple able to define, to implement the domains that we'll be trying to cover today. So, I have mentioned something which is called the algebraic data types. What are those? Well, at first, it sounds like it's something complicated, just taken from the maths. So, how many of you have ever met this term in the career? Well, only a few. That's bad. Well, algebraic data type, in its pure definition, means that it is a data type that can be formed from other data types. And the clue here is that what does this form mean? Well, there are two common classes of algebraic data types. It is the product, those are the product types, which may be found in the literature as tuple or records, or those are the sum types, which may be found as the coproducts, disjoint, or tag unions. And those are two different, because in case of the product types, it means that we are forming them by simply composing different types. And in case of sum, it means that we are choosing between types, or we are just simply summing them. So, when I'm speaking about the product types, they can be composed from 0 or more data types. 0 is a very special case, because if you are not using any data type explicitly, then it doesn't mean that product type is of cardinality 0. There is exactly one inhabitant in that case. So we say in many cases that it is the singleton type. In other cases, when we have at least one data type to be composed, we can treat it as a Cartesian product from the mathematics. We may have different sets, and when we do the Cartesian product on those sets, then we are taking at least one element from each of those sets, and we are building all of the possible instances. So how can we use the product types in order to implement some of our goals? Let's take a look at the game title. Game title may contain the main title, and it may contain the subtitle, which is optional. In Scala, it can be done this way. So we are simply defining the case class, which contains game title and the game subtitle. Option is provided by the Scala built-in library, and it simply implies that the value for the game subtitle may be present, and it will be a string instance, or it may be none. But in difference with the null that is present in Java, this option provides really rich standard methods that make this option operability much easier. It is even much richer than the inbuilt Java optional. So how do we treat such game title? Game title is simply a product type. Simply a product type of string and option of string. So We say that game title is just a product type that is derived from the string and the optional string. And also game title is a data constructor, which takes two arguments, game title and game subtitle. Let's take a look at another example. Let's take a look at the patch. Here, again, it can be implemented via the product type. And it will be a product type which will be composed from three different types. It will be the UID, string, and integer. And as we can see, the construction of the instance of the patch is quite easy. There is no new keyword required. It is very natural that we are taking the patch and we are applying the arguments. So we know how to construct the patch, and we know how to construct a game title. But both patch and game title, as you may remember, on each field, they had the end annotation. So we take game main title and game subtitle. Take patch ID and patch notes and version. But what in the case of game platform? Here, it is a choice between the PC, Switch, Xbox, PlayStation, and Game Boy. How do you think? Can it be implemented with the product types? Who thinks it can? Well, I was just kidding with this hand. So no, it can be, of course, implemented, but it will be very ugly. Because when you don't know how to implement such behavior, Boolean is your best friend. You don't know how to implement some disjunction, Boolean is the best friend. So the first take would be to use the game platform, and it will be containing five different fields, which will be Boolean. And they will be indicating whether the game platform is of given type. But it will be quite tedious to do in Scala when we are constructing such game platform, because we would always need to provide that if it's PlayStation, then PlayStation is set to true, and others must be explicitly set to false. So we can use the other inbuilt feature of Scala, which is the default arguments. In this case, when we have those inbuilt arguments, we can easily construct such game platform in the following manner. Those are the valid instances. Because, for example, PlayStation is constructed by using the PlayStation flag and set it into true. Also, Xbox is constructed by setting the Xbox flag to true. And it's not very nice because someone may accidentally put it to false, and it will then indicate that it's the empty game platform, which is not the case in our system. But there is something much more ugly. How may I interpret such instance? The game platform is set here to true when it comes to Xbox and the PlayStation. Which game platform is it, to be honest? Well, both is not really in our answer, because we need to somehow designate it. Also, game platform has this ability that we can't really evolve this design, because at some point in time, we may, for example, require that Xbox is versioned, the same PlayStation. Also, PC may be requiring, for example, the computer hardware requirements. And with this design, it will be a lot of effort put on the developer in order to ensure that our design is reflecting what it needs to do. The business logic will be heavily relying on the developer and unit tests. And I would rather like to avoid it. So here is where some data types come into play. So some data type is just a sum of other types, or it can be viewed as a choice between other data types. For example, if you've been working with the OpenAPI Swagger specification, there is this one-off keyword. And this simply reflects what some data type is. So in our case, game platform is just some data type. And how can one implement it in Scala? In Scala 3. Well, it is just enough to put it as enum. We have this enum PC, enum Switch, case of Xbox, PlayStation, and others. In Scala 2, it was not possible. That's strange, but in Scala 2, it was not achievable. It was only achievable with the external tools. But in Scala 3, it's an inbuilt feature. Since those cases do not contain any arguments, then we can go further and write it in a shorter notation. Those are just cases which can be interpreted as singleton types, as we can see here. Now, we can say that game platform is just a sum type, which can be either PC singleton type, because PC does not take any type argument. That's the case I was speaking previously about the product types. It's just a singleton type because there's exactly one instance of PC in the system, which is PC itself. The same is with the Switch, Xbox, PlayStation, and others. But those are just simple enums. Those are just possible in other programming languages. So why one should choose Scala when enumerations are also possible in other programming languages? Why it's the mess? Let's now complicate the situation a bit. And as I mentioned previously, let's, for example, assume that PC from now on also requires the requirement to be present. So, for example, we may require that CPU must have proper amount of cores and had a proper clock speed. Also, Xbox, as we may know, has different versions, and those can be 360, Series S, and Series X. Also, PlayStation can be versioned with 4 and 5. How can we model it in Scala with some types? Quite straightforward. We can make Xbox version also some type with proper versioning. The same can be done with the PlayStation version. But also, from now on, game platform is not just a simple enum that we used to do. It's now just a sum type with proper cases. Those all cases are product types. But now PC is not a singleton type. It is now a product type taking one argument of type requirements. The same with Xbox. It is a product type which takes one type argument of type Xbox version. And PlayStation, the same PlayStation version is taken as a type argument. So how do we construct data types of such type? Then it's quite easy. We don't need to really use any additional syntax to achieve that. It is just enough to use this quite easy syntax. So we take the product type of Xbox, we apply the 360 instance, and we have the instance of the game platform. So while it is easy quite to achieve, then there one may ask, OK, since it's so easy, how can we work on it? Game platform does not have any included methods that may operate on this abstraction. It is just a simple, maybe not marker interface, but it is just simply indicates that it may be disjuncted between those 5 types. So how can we operate on it? For this to achieve, we may use of so-called pattern matching. In functional programming, we assume that if one can easily construct a data type, then we should be also easily able to deconstruct this type. And this is the aim of the pattern matching. We take an argument of type game platform, which is a sum type, and we can, with match keyword, match between different cases. We can have a case switch without any type arguments. The same with Game Boy. But PC also can be deconstructed, and we can access its internal state. In this case, we call this internal state by rec. The same with Xbox and the PlayStation 4. And it looks quite nice, right? But there is one problem with this design. Do you see why? There is one small bug in this function. Just one hit is with the PlayStation. What's the problem with this design? Sorry, with this implementation. Yes. There is a problem that when we pass the version PlayStation 5, then it will blow our application. So that for Switch, it will print it in, it will work like a charm. But when we pass 5 to it, then it will throw the match error because our pattern matching does not know what to do in such cases. So I promise you that there will be some compiler help, that we will be working with a compiler in order to achieve our goals. But in the meantime, our code compiled successfully. We have run it. We are happy that all builds are green. But still, there is a runtime error. What happened? Where is that compiler? I hired him to do that, right? Well, I did something on purpose. Is that when you look at this function, you may see that GP is already highlighted. It was not done by myself in Visual Studio Code. It was something that was suggested automatically. Well, the case is that when we are using the enum construction, then since all the possible cases are defined in the same definition file, and this set of all possible cases is closed, compiler can infer whether all cases have been covered with our business logic or not. So in this case, I have forgotten to handle the PlayStation 5 version. So our compiler catch this issue, and it will print it on it will print it on a console as a warning, as a default setting. So as you may see, this information about the error is quite descriptive. It would fail on pattern case game platform PlayStation 5. So it is just a warning. But one can use the Scala build tool, SBT, which is a simple build tool, in order to ensure that if such warning is triggered, then not just only warn us about this situation, just fail the build. So if we have forgotten about the case, that's very critical. We don't want to have our production fail. So raise an error. It's better to raise error now during the development phase rather than fixing the cause that may happen on a production. So after we have read this warning and we have found that compiler informed us about that, now we can see that we have fixed this issue, and now it should work like a charm. And now you can see that GP is not highlighted. It is because most of the intelligent IDEs that are used in JVM development are also handling this case. For example, IntelliJ has really nice support for that, and Visual Studio Code for Scala 3 is working like a charm because it has a well-maintained language server protocol called Metals. So I highly recommend it. In Scala, there are also other additional enums, data types. Those are the option, the either, try, and the list. And those are the inbuilt types, so that option can be treated as optionality of some argument. We can either have the value present or not. Either is used in order to designate, in many cases, that something may go wrong. So on the left channel, there will be the information about an error. But on the right channel, there will be the present instance, if it's everything OK. And also, either can be found in other languages as the railway-oriented programming. The try is used in order to work with Java functions that are not a capsule, that are not showing the type signature, that they may throw an exception. So the function is acting in a deterministic way, that for given input, they are already returning the same output, but they are not including the information about the exception. So that try is responsible for wrapping such call and handling in a way that if call finishes successfully, then success is emitted. If not, then there will be a failure with an exception. So rather than using try and catch clauses in your code, you can just use try data type. It contains also a really nice set of methods that make this type really interoperable. Also, there is a list. In a functional way, we have two cases. Either a list is empty, or a list contains at least one element, and it may reference the rest of the list. That's how it's implemented. But of course, in Scala, in case of list, there are some optimizations, so you won't find the exact form like that, because tail is simply a variable reference. But that's not the case here. So coming back to our problem, how can we model such game in our code? We have OR, we have ANDs. We know how to model things with sum types, and we know how to model things with product types. How can we use our enum construction and product types to use it? Quite simple. We have enum game, which has two different cases, in progress game or released game. Those two different data structures contain different fields, and we are explicit about it. We don't have to create one monstrum class that will contain all possible fields as a mixture between those two data structures. We just create enum type, and we are specific which state may contain which data. So it's quite straightforward. But there is still some problem with this design. We are overusing the primitive types, UID, string, instant, and integer. For example, from this design, when I look at it, I can say that game ID is of a UID of some expected format. I can't say that studio ID is a string that must be non-empty, must be of a specific format with int or ext requirement and 6 digits. I can't say it. I don't see it. The same is with the latest version. Latest version must always be bigger than 0. Here I can pass -2, and everything will be fine. Our system will behave normally, unless we will be responsible for ensuring that those operations are working. So that we will be responsible for covering the business logic with our unit tests. We will be responsible for remembering that each of such type has those constraints. Over the time, it will be very problematic to us. So how can we mitigate? How can we solve this problem? We can solve it with a construct called opaque type. Opaque type is just an alias for a type. So it's just a rename, but with some more power compared to the simple renaming the type. Opaque type has this property that it wraps the type, and in the place where it's defined, we can do everything with the underlying type. So we can change game ID, UID, which is that underlying. We can do everything what we want. But for external use, when we are outside of this game ID, or the object that already contains this game ID definition, we can't do anything about it. So inside the definition, we will see that game ID is UID. We can do whatever we want. But outside the definition file, game ID will be treated as a completely different type, at least from the Scala point of view. So when we are, for example, using this game ID in our representation of the domain, then game ID will be treated as a game ID type, not UID. So that's very important, because in order to create such instance for the external use, we are now conscious that we have to use the proper functions called smart constructors. Smart constructors are just functions that are responsible for creating the instance of given type, but they are also responsible for validating the input. In our case, we have the game ID, which is UID. When we have the UID from the system, for now assume that we don't have any restriction on that. Take the UID and cover it. If we have it from string, that's the different case. String can be empty, which is not a valid UID. So UID from string function must be used. But there's a problem with this design, that UID from string is a function that is returning UID from the type signature. But the problem with this type signature is that it is not explicit from the Scala point of view that it throws an exception. So we can fix this issue by using the try data type. Try data type will be responsible for taking this from string, applying this operation, and catching this exception. We can then use the inbuilt methods on this try and properly handle this case. Rather than returning an exception, I decided to put this information as a string, which is not a nice pattern, but for the case of simplicity, yeah, it is sufficient. We don't return an exception. We just return a string, and it can be easily done with just a few dots. So that's fine. But we may have the cases where, for example, we have the game main title and subtitle. As for now, all we know is that those types can be empty. Those instances can be empty. So it will be quite tedious to write again and again the function that will create the non-empty string validated each time and others. So in Scala, it was not possible. In Scala, there was a concept so-called of value classes, and value classes could be nested. Value class couldn't reference other value class. In Scala 3, that's not a problem. This is the big benefit, because we can prepare some inbuilt special types like positive, integer, non-empty string, and others, and reuse them in the places that we want them to be. So firstly, I decided to write a non-empty string, and then I can reuse it as a game main title and game subtitle. And that's fine. But over the time, writing those functions may be very, very time-consuming. So we can just, make use of the refined project. Refined. It contains some common rules of validation, like non-empty string, positive integers, regex validations, and they can be reused out of the box just by attaching this library. This is how it looks with the refined types. It looks this way. So we have the string refined matches regex. It will be responsible for such validation, and we can easily create the instances of such studio ID just by using the provided smart constructor called apply. Here are the examples that when we provide the valid cases for the studio ID, then we'll end up with right case. But when something is wrong, then we'll end up with left. This predicate failed is not a really nice message, and it should never be pushed to the client back. We are responsible for overwriting, but still, we have a good base to start. So, given now we have those opaque types, what can we do? Yes, we can improve our design. From now on, we have the game ID, studio ID, game title. We have the timestamp. I did it for the case of simplicity, but still, we have game platform, game title. We have the path. Great. We have also the non-empty list, which is coming from the CATS library. Really worth checking, because it's a very hugely adapted in the environment. So given such design, when you look at the left and the right, one may say that when we take a look at the left and the right, they are the same picture. Because I can easily look at the specification, and I can easily look at the implementation, and I know at which place I am right now. I know which fields will be missing. I can even go one step further and show this file instead of the left one, show this file to the non-technical person, and most probably, just with few explanations, he will understand, or she. They will understand the purpose of this file. But while the design has improved, in this case, we have the data integrity improved because now the game is not responsible for improving for the integrity of the data. Now those data are defined as different data types, and there are rather smaller functions rather than a few bigger ones. So it is improved. But there is still one problem with this design. It is still about the data consistency. With the case classes, there are so-called copy and apply method generated, and they are of public visibility. They can be used anywhere in the code, and no one will even complain about it. As we can see, we have the aggregate of our game, and we can use the copy method to append the path. But the problem with this design is that such path can be appended, but the version won't be bumped. And we can do it in any place in code. So that's rather not what aggregate is responsible for. Aggregates are responsible for making illegal states unrepresentable. So we have already used the sum types, the product types to do it, but still we have this leaky logic that may do a lot of mess. But there is one small fix for that. We can just make the primary constructor of those data types, of those product data types, private for some package. So that those copy and apply methods and this constructor will be only visible within the FDM package and FDM subpackages. That's how it work in Scala. And outside those packages, that won't be visible. So as long as, for example, you don't put the infrastructure-related logic inside the model, that's not the case, I think, then this design is safe. From now on, if you want to manipulate the aggregate, you need to do it inside the game enum. There is no other way. So we are enforcing the consistency using this design. So from now on, our data is consistent. Now the whole logic sits inside the game aggregate, and it can really leak outside. All the changes must be done via the prepared methods. So everything would look fine. We're a bit over the time, but just 2 more minutes and we should be done. So this design, we have the consistency, we have the integrity of the data, really nice expressive design. Compiler helped us a lot. But with such design, everything was fine because this aggregate was small. There were just a few product types involved. But maybe let's start with this case. How do we, as a functional programmers, change the light bulb in the room? Just taking the light bulb and putting it on the lamp is just like a word mutation. It's not a pure function. So how do we do it first? Well, firstly, we copy the planet. It's filled with the oceans. Those oceans now are ready to have the continents put on them. So as we put those continents, we copy the mountains, forests, and others. We can, of course, remove the pollution from the air, but that's not the case for now. And as we have copied the mountains, forests, and others, we can copy all the buildings, cities, and others. Even with my room, I can do it as a functional programmer. And as this procedure is finished, I copy the contents of my room. Now I can copy my bedroom, my wardrobe, and my desk, no problem. And in the end, I can change the light bulb. That's all. Quite easy, right? Not so easy for the business logic implementation, because if the logic is very deeply nested, the aggregate is very, very nested, then trying to update one simple field may result in a disaster syntax. Just look at it, it's really unreadable. We have field 1, field 2, field 3, field 4, and others. I can't even say it quickly, what else to do with that. So that there is a big problem in functional programming with manipulation over these data types. So how can we fix this problem? Is there any way to do it? Yes, there is. We can't mutate the data structure in place. But in functional programming, we make use of the concept so-called lenses and prisms, or generally speaking, the optics. They can be used to take a look at the getters and setters that are present in other languages in a functional way. We are abstracting over it. And the purpose of them is that we decompose the data access from the operations that we do on them. So there are two main projects that are solving this issue, called Monocle and QuickLens. I will show an example from the QuickLens. This is how we can do it with the Monocle. This is how we can do it with Monocle with the so-called Focus API. You are just specifying the path to the data portion that we would like to update. And when we have this update, this data path with Focus, we can then set the field. How it works under the hood? This is another great benefit of Scala, which has the compile time generation tools so that we can manipulate the abstract syntax tree that is generated for this language, and we can easily generate the code that will be boilerplate. We can easily, for example, generate the lenses for this case, but we can also do one further, JSON codecs, HTTP schemas. It can be accessible in a really nice way with the compilation tools. So that will be all, and I highly recommend you to at least look at some of those books. I mean that if you are really interested in domain-driven design, but you would like to combine it somehow with functional programming, then the first book is a must, in my opinion. And also the fourth one, functional and interactive domain modeling, is a must, because those two show how to use functional programming languages in order to implement the domain in a functional way. But also there have been a recently released book called Learning Domain-Driven Design, which is a great choice for current situation, because if you don't have the time to read the whole blue book by Eric Evans, then this book will be a really nice brief overview how we can use domain-driven design in our development. But if you are familiar with DDD and you are just would like to get familiar with functional programming in Scala, then the red book, so-called the second position, functional programming in Scala, is a great choice. It contains a lot of description over the concepts that may make you look completely different on how you compose your software. And also there is a programming Scala book, which is updated to Scala-free syntax, starting from the most basic concepts to those even covering the code generation tools. And that's all from me. I would like to remind you that as Evolution is growing and growing, we are hiring with really, really many great developers. So if you are interested either in gaming or distributed system, microservices, JVM-related topics, or Unreal Engine, then this company is for you. Great, thanks for your attention, and sorry for delaying.